In this video, we're going to discuss activation functions and max pooling. First, we will talk about the activation functions. Then we'll discuss max pooling. Let's talk about activation functions. Using the activation map, we apply the activation function to each element in the activation map. We get an output tensor that is the same size and shape. We have the input image tensor X and perform convolution and get the output tensor Z. We'll then apply the activation function. Let's do an example. We will have our input image. We will have our kernel. We take our input image. We perform convolution. We have our activation map. We apply the activation function. Let's look at the output. We have -4. We'll apply the ReLU function. We get 0. This applies to the other elements in the column. We'll apply the ReLU function. We get all zeros. For the second column, we have all 0 values. We'll apply the ReLU function. We get all zeros. For the final column, we have all 4s. We'll apply the ReLU function. We get all 4s as the output. When the activation function is applied to multiple channels, we simply apply the activation function to each element. We can see in this example, all the negative values are set to 0, and the other values remain the same. In PyTorch, to apply the activation function, we have an image. We perform convolution. We then apply the activation function. If you would like to use the sequential method, we would create a ReLU object and apply it. Now let's apply max pooling. We will review one of several variants. Max pooling will reduce the size of the activation maps, reducing the number of parameters. It will also reduce the impact of small changes in the image. Remember our last diagram. We usually apply max pooling to the activation map. We have an image. We have a region of pixels of shape k by k. We simply choose the maximum value in the prescribed regions. We have the following region. We simply select the pixels with the largest value. We shift the region and repeat. Just like convolution, we repeat the process. We stop when we get to the end of the image. In addition, we can create a max pooling object and apply it to the image. With the region size and stride, the result is a new tensor. The shape can be determined just like convolution. We can also apply max pooling directly to the image as a function. If we set the stride equal to none, the default parameter, we shift the entire area per stride. We get the following outputs. We continue moving. We can represent the pooling as follows. Max pooling helps by making small changes in the image have less impact. We have two images. They are identical, but one slightly shifted. We apply max pooling. We start shifting. We see the output is identical now, and that's it.